Hi everyone. So right now I'm going to give you the demo about the heartbeat sensor. Show to you how to wire and the coding and the running. Wiring like this. So actually, as you can see here clearly. So this is a sensor. What happens is that this IL lights comes from here, and that this is the thing that you place your finger here. So this is a light sensing you, and then actually your heartbeats can be counted by this small panel here. Okay, so this is LED lights, and this is some of the detectors, and 3 pins required. On the left side, that is the ground. In the middle, there is a power, 5 volts, and then brown, that is the data, the cable. So data cable goes to the pin number 7 here in board mode, and then black ground, 3rd pin from top on the right right side pins, and then the number 2 pin on the top of right side pin. There's a red cable, which is the power lines. So I wired it like this. Okay. The way that I explained this, I'm not sure if I show this well. Okay, so with that, and then next one is a code. This is a code that you can see here. Remember that in your homework assignments, I want you to put your first name and last name. Only your first name and last name, that's exactly the same one that I can see from your Blackboard name. I'm going to register your first name and last name on my cloud middleware program. So this first name and last name, and then read the sensor data from the pin number 7. Remember that I hear board mode. Okay, this is a board mode. These 2 things needs to be done carefully. But today I'm not asking you to post your data to the cloud server. But for this, I want you to practice this. Remember that in any the homework assignments, when you do this, I want you to put your first name and last name. And GPIO can be set in this way. The set number, pin number 7 for GPIO in mode, and return pin number signals, okay, which is pin number 7. And then I have a while loop. Remember this continue. That continues changed when the count is greater than 10. And then I put here sensor model and then type. Type is this misspell heartbeat, and then this is the model. And the data that can be obtained from invocation of these functions. If count is 0 at the very first time, I want you to say put your name, first name and last name, and then sensor model and sensor types. If it is a 10, then that is a stop. Otherwise, heartbeat the value. Okay, that can be from my data, which is this, right? Let's keep going. So when I run this, well, actually, I have the program here. This is my Raspberry Pi that connected to this. Remember that? This is what it is right now. So I want to run that program, see what happens. Python 3 and wire that. And the way that I can capture, as I said, I need to place my finger here. Okay, so I will do that. So my heartbeat is counted. I think I put that about 20 times or 21 times. Okay. So now you may be able to see why there's all one. Because actually this this sensor gives you the analog signal rather than digital signals. And the Raspberry Pi can receive only digital signal only. The analog signals cannot be acquired by your Raspberry Pi. So there is a gap, technical gap. So in order to resolve that issue, here is what I did. And I did, logically it is okay. So what I want to do is I want to bring up Arduino UNO. Okay. If I show to you Arduino UNO, then this is the Arduino UNO. Okay. Arduino is another microcontroller. Has been the longer history than Raspberry Pi. Here at Mercer University, we used this Arduino UNO 10 or plus years ago. So we have lots of student projects with this, but not anymore. Mainly because this Arduino UNO, without modifying the OS completely, then the language that is used for this, the Arduino UNO, is C language. So we try not to use that. And instead, we moved to Raspberry Pi. Now Raspberry Pi has a little bit issue because of no analog data can be captured. So I want to find out the way that I can use both Arduino UNO and Raspberry Pi so that they can be bridged together. Okay, here's the things. We first learn Arduino, right? This is Arduino. Arduino UNO has two program the functions, setup and loop. In setup, we usually set the baud rate, like data speed, and in loop, we simply continue to these three statements. In the first statements, analog data can be read, and then this print statement, if this is connected to Raspberry Pi, then it goes to Raspberry Pi by having this print ln statements, and then delay 100. Okay, this is what we used to have. All right. So I want to see right now, hold on, I need to bring up the connector. Okay, now this Arduino UNO, this sensor, heartbeat sensor was connected to the analog pin here, the pin number A0, the left ones, and then same thing here. There is a power line and ground that is connected, and I'm going to show to you that is directly. This is another USB cable from this Raspberry Pi, goes into my laptop, and then this is the program that's, I'm going to bring that up here. Oops. Okay, so that is, this is the code. We have the first function set up, and then second function, the loop. Delay time is 1 second. I think that is, so 100, it's 1000, right? Which means 1 second. Every second it gives me some of the data. And the button here, so that I can verify the code. So to close this, close that. Oh, missing the board. I need to choose here Arduino UNO and then verify. So compiling, it's good. And then I'm going to the upload by clicking this. So upload is good. So I don't need this anymore. Close that. And this is my slide. Come back here. So I've done this, and now unplug my Arduino UNO from my the laptop, and then I am going to plug this. See here, this is my Arduino UNO. This is the Raspberry Pi, and I am connecting this into here directly to USB. So my the Raspberry Pi has actually there are 4 the slots for USB, right? I use 2 slots for the keyboard and the mouse, and then this blue ones, that is for this Arduino UNO. Okay, that is connected. Well, actually, when you do this, depending upon your Arduino, no, depending upon your Raspberry Pi needs to understand and needs to identify your USB, the port from which the external data coming into your Raspberry Pi. So you need to find that out. So in my case here, for example, ls /db, that's for the device. So if I want to see TTY, the terminals, then I do have all, and at the end I have a TTY ACM0. By default, you may not have this, right? Then you have to set it up in many ways. the one that I found out, if I can share with you, and also if you are interested in. Oh, I don't have that here, but anyway, usually either TTY ACM0 or TTY USB, one or the other needs to be available. If it is available, if it's not available, then you have to set it up. So there's a long way that you can go. So because that is available, so I call that Arduino port, and then baud rate 60 and 9600, and then I want to import a serial because from my Raspberry Pi, my Raspberry Pi does not have that sensor, right? But my Arduino UNO has a sensors. Arduino UNO, this has a sensor. My Raspberry Pi, look at here, the pins, they're all empty, right? So the GPIO is not necessarily needs to be imported here. Only serial, because I'm using that serial port here, TTY ACM0. And the connection here, this serial has the object, the constructor called the serial. It takes the port number and baud rate and timeout. Then we will have SEL object. This is a serial port object. This is a serial port object. This is initial we done. And then in while loop, that serial object has the function called read line. Okay. And then this the data that this Raspberry Pi receives is the byte code. So we want to decode it to UTF-8, which means that is readable. Okay, if it is a byte type of data, usually over the Python codings, if you have some experience, if you send the data over the internet, either wireless or wired, if you want to send out the data through the internet, then it goes out in special format. It is called the byte. Not the text data can go out or can come into your Raspberry Pi. So all the time it should be in byte type. So when you receive in byte type, then you have to convert it, we call that decode, into this is type settings, the regular ASCII formats. And then we split that, and then we call data, and that data is a number. It is not number initially, it is in character, so we convert that to integer. And then we print out. Heartbeat rate is nothing but a sensor value, which is this integer format of that data. Okay, that is keep doing that. So our Python code is not the Python code that we built as if we have digital data, right? This is for analog data and receives from the Arduino UNO. Simply, in this case, your Raspberry Pi, take it, simply the data, and display. So that's program is in, let's see what it is. I think this is read arduino.py. I need to check. Cat read arduino.py. Yes, that program. So we need to run that. PI. And I'm going to show here. See here. I need to put my finger in between the sensor. So I want to hit. What happens? Oh, this is not. What did I do? Oh, this is for PI. I need to do Python. Python 3 and read that. So hit enter. I'm going to run that program. And meanwhile, want to put my finger. See, that is rather than 1023, lower and lower. Okay, that's a heartbeat. If it goes up to 1023, then my heart beating fast, which means almost 60 or 70 per minute. Because I am talking right now, it goes bigger, right? So let's see. So if I don't do anything, then it is 1023. It kept 1023, which means when I run my program on Raspberry Pi only, as if it is digital data, then it gives me all 11111. That is nothing but 1023. So when I place my finger here, I think there's a number 990 something. That is the actual the heartbeat of mine. Okay. All right. Okay, so I'm going to skip. Stop that. All right. This is the end of this program. So what I did was here the Raspberry Pi checked TTY USB or TTY ANC0, and Pi serial needs to be imported because the serial is imports. So you can do on your the Raspberry Pi PIP3 install Pi serial. If you can install Pi serial with the no error, then you can do that locally. But if we have an error, error says the external the packages cannot be installed if it is not known by Debian the Linux, then there is an error. In that case, you need to put these options. Okay. -- break system packages. What that means is that do not check the system packages. It goes into the system levels. That is the reason it doesn't allow you to install. Remember that the serial port, using the serial ports should be done by the system levels, okay, not by your application layer. So that is what we learned. Okay, this is the end of the demo, the little bit of the complicated configurations, because we use both the Raspberry Pi and Arduino and handles analog data. So a little bit of technical trickies, a little the advanced hands-on skill needed. Because you guys, when I see this, that reminds me of something. Here, happy birthday to you, .py. This is the code that I made. So I'm going to play that. This code generates the song, the happy birthday to you. I am thinking of as the heartbeat data is collected, or any other sensor data collected. Each sensor, one data comes in, then I can play this data come in certain speed. So I'm going to mix this Python code to data collection Python code. Currently, sensor data collection runs independently from this the music data. So I want to listen to this music data. I am going to explain this the code next week. All right. Thank you. I'll see you next week.